All right, so on example 5, we're going to simplify this. And so yesterday, the directions would say things like rewrite so it only has sine of x or whatever. But this is going to be a little different. We don't have like a goal. On your assignment, it's going to be like the back of your worksheet where you have choices to end up at. So that does help if you have like a goal to go towards. But one of the things I wanted to practice today is adding and subtracting fractions that have tangent and cotangent, different things in it. I don't feel like you've ever done that before, but it's gonna be fine. Okay, so one of the main things we did yesterday was write everything using sine and cosine, and that's what we're gonna do for example 5. The first thing we're gonna do is take each one of these parts, each one of these trig functions, and rewrite it using sine and cosine. So you're going to want to have this guy from, we did this earlier. All right, now that cosine of theta, I just went ahead and put it over 1 just because we're multiplying it by a fraction. It can get a little bit confusing. All right, so on this fraction, whenever I multiply these, you should get cosine squared of theta over sine of theta. This one actually works out kind of nicely because you already have a common denominator. And so whenever you're adding or subtracting fractions, once you have a common denominator, you can make one big fraction and put the common denominator as your denominator, and then just add or subtract the numerator. All right, and then where are you going to look if you have a 1 and one of the squared trig ratios? Pythagorean identities. So look at your Pythagorean identities. There's only one that involves the cosine squared. You have to manipulate it slightly, but what does 1 minus cosine squared of theta equal? Very good. I do not like doing a whole bunch of equal signs in a row, but it's okay if you do. All right, and then if you have sine squared of theta over sine of theta, one of those signs is going to cancel out, and what should it leave you with? Yeah. And that's it. Right. Now, example 6 is going to be slightly more difficult. If you were doing this on your own and you looked at that, you would probably think, okay, I'll just write everything in terms of sine and cosine. And I'm not sure if I tried that because I can kind of see where it's going. And so it's easier for me because I've been doing this since before you guys were born. But if you did write it as sine and cosine, it might lead to something that would help you. But there is a better way to do it. And it's going to be to actually subtract these two fractions. Even though this doesn't look like a fraction, it is if you put it over 1. But what do you have to be able to subtract those? Common denominator. And what is it going to be? What is the common denominator going to be? Only one of them actually has a denominator. It's going to be tangent. So tangent of x needs to be the common denominator. So we need to make this one have the common denominator. So what would we multiply it by? We'd multiply it by tangent of x. Now, is it legal to just do that? Mathematically legal? You also have to do it on the top, because if you multiply the top and bottom of a fraction by the same thing, that is like multiplying by 1, and that is always legal to multiply by 1. Okay, so now that they have a common denominator of tangent, we can make one big fraction with tangent of x as our denominator. And you guys figure out what you think the numerator should be. So when I multiply tangent of x times tangent of x, I get tangent squared. And then I just bring over my minus secant squared of x. All right, where do you guys think we should look on our identity sheets? Probably Pythagorean identities. And what we're looking for is to take one of them that probably has the tangent squared of theta and secant squared of theta and make it look exactly like this. We're going to have to move some things around. So I'm going to write it over to the side because it's kind of hard for me to talk about it when I don't see it. All right, so we're going to move some things around. So I get tangent squared of theta minus secant squared of theta. So that would mean I would subtract the secant squared. What would I do with the 1? Subtract it. So I took that identity and I kind of manipulated it. So that whole numerator, what is it just equal to? -1. Good. So I can replace the numerator with -1. All right. And then what do you guys think -1 over tangent of x is? Negative cotangent. Good job. All right. Okay. Let's look at this last one. This last one involves squaring a binomial. It's not really a binomial because it's not a polynomial. So squaring two terms that are added to each other. But we're going to go back to an old rule that we've talked about throughout this year. So if I wanted to square just a plus b, do you guys remember that rule? You square a. You multiply a and b together and multiply by 2. And then you square b. It's the exact same thing we're going to do, but A is going to be cosine. Nope. A is going to be sine of theta, and B is going to be cosine of theta. So we'll start off, and we're going to square sine of theta. So that's going to be sine squared of theta. Now, one thing that might come up on your worksheet is if this is a minus, I didn't mean to make it. If this is a minus, then this sign is a minus, but the other one is still going to be a plus. All right, so we have a plus here, and then we're going to do 2 times sine of theta times cosine of theta. And the last sign is always going to be a plus sign. And then we're going to square cosine of theta. It's cosine squared. Okay, so if you're looking at this and you're looking at your identity sheet, is there anything that jumps out at you? There's actually 2 things we could change. Yes. So if I have sine squared plus cosine squared, what is that going to equal? That is going to equal 1. All right. There's another identity that we haven't even talked about yet, that we're going to talk about tomorrow, that ends up equaling 2 sine of theta cosine of theta. Do you guys see it? Yeah, it's a double angle formula. So we could change that to sine of 2 theta. But the main thing I want you to get out of that is the sine squared plus cosine squared of theta. That's going to be 1 every time. All right. What questions do you guys have? Okay.